Okay. Hi everyone. Myself Shanmuga Vadivel from Ramcatches Private Limited. I'm here to present important future update in IDEA StatiCa, which is released in the version 24.0. For some of the new audience, to know what IDEA StatiCa will do, I would like to showcase the workflow of the IDEA StatiCa software especially in the steel program. Um, so let me go to the software and let me show you how we will be able to perform the steel connection design in the software. So I'm choosing the connection module. Basically, the software will allow you to enter to give an input in terms of class, geometry, and design. So we can select our recommended connection design which we want to perform according to our requirement in the class geometry as well as in the design. And in the parameters, we can enter the name of the project, the description of the connection joint which you are able to perform, the design code which you want to perform the connection design according to which country code. You can select it from here. So the list of available country codes are covered major like European, American, Australian, Russian, Canadian, Hong Kong, Indian. So as per choosing the country code accordingly, we can able to observe the steel grade, the differences in the steel grade, the bolt assembly, the weld grade, everything gets changed automatically. We can select we can select the required material before we proceed with our connection design. So let me choose an European code and we can go with the splice type of connection. We can give a splice name for this connection type and we can create a project. So once the project has been created, we are able to identify the member property. If we want, we can able to edit the property of the member from the shapes available over here. And we can able to explore the other shapes of the cross sections in the cross section navigator icon window. And these are the list of rolled sections available. In the welded or composed sections, we can able to give heavier sections if you want. Say for example, if you go with the box web of sections, you can define your own parameters and proceed with the selection of your own cross section. And we have the general steel cross section editor where we can able to provide we can able to develop your built up profile sections from here. With the available cross sections, we can develop your own built up profile sections, maybe like with star column sections by using the I section and the T profile, or I section with the web plate, or I section with the flange plate. Anything you can develop from this general steel cross section editor. And we can able to use code form sections. So these are all the sections available to proceed with the connection design. And we have to choose the appropriate geometrical type and appropriate model type necessary to get the exact results. It is in the user's hand actually. And then we have the load effects. So we can able to import the load from Excel sheet by using this icon. We can able to get the load from a previous IDEA StatiCa file, and we can able to create your load case manually over here. Next comes the operations. So we based on the selection of operation, you can able to um, give the parameters required for each of the operation, and you can edit the plate, the bolt numbers according to your requirement in the operation, and you can proceed with the connection design. So from these icons, if you want to add a member, you can choose this add a new member operation. If you want to add a new load case, you can choose this menu. If you want to use any other operation, irrespective of your connection topography you're choosing, you can explore these available operations according to your needs. You have to just select the operation and give the parameters. The operation will get accumulated in your connection design. So once everything is done, the modeling wise and the loading effects is been given. The load effects has been given as an input to perform the connection design. The next step is you have to choose the code setup. You have to make sure ensure the safety factors, the settings, the modeling and meshing arrangements is all well suited for your connection design needs. And after checking these requirements, you can calculate your connection design. So once the design has been over, you will be observing the preliminary result at the left top corner in the graphical user interface of the software. And you can observe the detailed result in the check tab. You can observe the stress distribution in the mesh formation. You can observe the stress distribution in the tabulation formation over here. The bolts utilization can be observed from here. You can observe the strain distribution. The whole methodology of analysis of the IDEA StatiCa software has been followed by component-based finite element method. So it will be the results are observed for the plates through the finite element analysis, and for the bolts through the empirical formula as per the codal provision according to your country code which you are choosing. Next, we have the buckling analysis. You can run the buckling analysis through the calculate button in the check tab. And after the buckling has been done, you can observe the buckling shape over here with the buckling factors. You can observe the different buckling shapes for the different factors. So along with this, we can get the report in the report tab. We can choose our required theoretical background, software information, the bill of material, the cost estimation, the formulas used. So everything has been selected as per our requirement, and we can generate the report. The report can be exported to the PDF format. The bill of material can be exported to the DXF format. The report also can be exported to the Word format. This is the sample of the this is how the report will be looking like, along with the member designation, the force allocation. We have the bolt designation, the load effects which you have given. Then we have the plate result, detailed result for the plate, pictorial representation of the stress distribution and the strain distribution, bolt utilization, and the detailed result for the ultimate value of the bolt can be observed in the report. And then we have the bill of material and the cost estimation. We have the code setup, and we have included the theoretical background. It has been displayed in the report. So this is how I'm just explaining this to the new audience who are new to the IDEA StatiCa software. Just an overview of how the workflow of the connection design would be. It's a very user-friendly software, very easy to handle, and require minimum consideration on the inputs to get a efficient output from the software. So now let us see the futures. Let us see the future update in the latest version 24.0. So IDEA Statica has been in the industry for the past 10 years. We are celebrating the 10th year in the current 2024. We are giving with beautiful offers for our customers. So lots of enhancements have been made through the latest updates in the previous versions also. Let us see for the latest 24 version some of the important future update which will be more prominent will be using in our day-to-day usage of the software in the upcoming slides. So we have the automatic weld sizing, an update the developers have been imposed in the software. So the weld sizing, it is automated in four conditions actually. The first will be it is the automatic weld sizing according to the minimum ductility. This feature is being designed as per the Euro code 1993. The clause has been mentioned. So when on a single click, this weld has been performed in the software in your connection design. It will prevent brittle failure and it will allow the plastification in the connection weld. And we have the full strength, the automatic weld sizing according to the full strength. That is another option we have been updated by the in the software. It will produce thicker welds than the weld sizing due to the minimum ductility. The resistance to the weld is more than the resistance of the plate that is connected to the edge. So it will not allow brittle failure before the plate fails. And the other option, we have the automatic weld sizing according to the over strength. Even more thicker welds are produced from here. The welding is very strong here in the connected plates. The weld size is multiplied with the over strength factor from the settings tab. So we will see in the software how this automatic weld sizing is being used actually. Let me go into the model. So in the automatic weld size, yeah, we have this feature that can be observed in the operations tab. So once you click on the operation, you have the weld sizing method listed upon over here. So we have these four options available. Weld sizing method to capacity estimation, to minimum ductility, to full strength, or with over strength. To capacity estimation, we can to decide this capacity estimation that is governed by in the settings tab. So in the settings tab, if you can go to the design option, inside the design option, you have this general, we have the weld specification as throat thickness. The beam resistance percentage we can fix up over here as a 40. And in the operations, in the auto design, you have this over strength factor as 1.40. That is will be helpful for the automatic weld sizing according to the over strength factor, and the target utilization for the weld, that is 0.9. We can fix up over here. If you want to have an edit, you can have it over here in the design tab. So the software will be calculating this auto design according to your value that you are giving as an input in the auto design option in the settings tab. So once to the fullest capacity of your connection design, the weld sizing has been performed over here. And you have to just calculate the weld sizing option. That is enough. It will give you a result of the weld in the top left corner. So if you change the weld sizing to the minimum ductility option over here, and if you run the software with the weld sizing option, you can observe the result over here. For that, you can observe the flange weld over here. It is being auto designed actually as 5 mm and 3 mm through thickness for the webs. And you have this full strength option running again. Then we can run with the over strength option. Yeah. So with the over strength option, we can observe the change in the weld throat thickness for the flanges and ribs over here. I think we have got some questions. Okay. The weld grade, automatic weld chooses the higher weld grade material or lower weld grade material. It is depends on the grade material which you are choosing actually inside the software. The software won't choose your material weld grade according to your. The software won't choose the material automatically. It will give you the size of the throat thickness according to the input which you are giving as a in the settings tab. So that is mandatory for this automatic weld sizing. So next feature we have this auto design of bolts in shear. So this auto design of bolts in shear is very much applicable for the fin plate arrangement as well as for the splicing arrangement for the connection design. Let me go inside the software. For the fin plate. Yeah. So for the fin plate, you have to just right click over the fin plate, and this auto design of bolt option is added as an additional feature here, but this is disabled. To enable this feature, you have to calculate the software, calculate your connection design. Have to make sure that everything is passing according to the analysis is 100% sure, and plates are everything is within the limit that is mandatory before performing any update. So once we run the analysis according to your loading conditions, and you can right click on that, you have this auto design of bolt. I have run with the minimum loads only. So it as a checkpoint, if I click onto this auto design of bolt according to the loading condition, it is just allowing me to um, provide this size of the fin plate. The size of the fin plate has been reduced two along with the two bolts only. I have just checked as a checkpoint. I have minimized my loads and run the fin plate to check the auto design of bolt feature. So this has been this is the result we have got actually. This the especially this feature, it is controlling. It is being controlled by the number of bolts, the thickness of the plate, the the bolt arrangement. Everything gets influenced by this feature, and we can control this settings from the design tab. Yeah. So in the general, we have this in the bolt assemblies. It is our responsibility to ensure the end distance, the edge distance, the spacing, the wall distance, everything for the detail, the bolt detailing as per the your recommended values. So based on these values which you are entering in the design tab, that is being reflected in the auto design feature mm, in the auto design feature after you perform the analysis. So in the operations, you have this bolted operation, the maximum number of fin plate. Yeah. So you have to increase the number of fin plate bolt rows if you want to have an extended number of bolts. So in the auto design, the utilization capacity also is decided. The utilization percentage has been fixed here over as zero point 0.9. If you want to increase or decrease, you can make that edit in this design tab on the settings. So based on these values which you are giving, the after you perform the analysis and then you enable this auto design of bolt for the fin plate arrangement, the the results being observed. Yeah, the results being automated according to your requirement. The software will give an automated results based on the input which you have. Yeah, very simple as that. So as an explanation of auto design of bolts in shear, we can see here can suggest the efficient design of fin plate or the splicing arrangement, taking into account the shear load. The layout of bolts is automatically adjusted to withstand the load and keep the given level of utilization. It influences the number of bolts, geometry of bolt grit, geometry of plate, thickness of plate, while the diameter and the material of the bolt remains unchanged. It is our input, the diameter of the bolt and the bolt material grade is given as an our input. The software won't suggest the required diameter and the required grade of the bolt. It is our input. The software will suggest you the number of bolts, the geometry of bolt grid, and the geometry of plate as per the input which you have provided in the settings tab. So that is about the future update as the auto design of bolts in shear. And next we have included partial joint penetration groove weld in the American code. So we can open any project in the American code. Let us create a project. And in the cut operation, where the wells are being influenced, you can observe the partial joint penetration in the weld area. You can make this flanges as a double side fillet weld, and you can make the web as the groove weld. You can calculate the weld sizes for that. So this is the future that has been brought in by the developers for the American code. And next we have the steel pins. So it is another future update that has been implemented by the developers in the version 24.0. So typically connected bracing, the pins have been used in these areas as a diagonal, as a bar element, other structural that will transfer the tension and compression forces. As we all know, such a connector type is the ready solution in the IDEA StatiCa connection app. So while choosing the pin, by default, you have this item count as 3. A pin has been performed. A separate checklist been observed for the pin analysis. The calculation formula will be observed from the after the result we have in the report page. So next we have an important update, that is hook anchors or the L bolts, especially in the American code. So in the software, in the American code especially, you can go to the base plate arrangement, and the American code has been listed out with this list of available codes available, AAC 360 from 10, 16, and 22. LRFD and AST both are available. So we can create a project over here. And in the base plate arrangement, we have this anchor type, and in the anchor type, you have the hook. So these hook, you can define the length of the hook. So yeah, you can increase or decrease from here this option, and then you can allow the shear force transfer through friction or shear leg or anchors or through sliding. Next comes so after giving your recommended input in the base plate parameter, you can calculate your base plate design. Yeah, we can observe the failures based on the load inputs we have. Maybe you can try with just trying. So in the check tab, you can observe the result of the anchor. You can observe the detailed result of the hooked anchors over here. The concrete breakout tension, breakout resistance of anchor and tension, the concrete pull-out resistance, the shear resistance of the hook, the concrete pry-out resistance. So these results will be elaborately available in the report column also. We can click on these formulas for the extreme value and we will generate a report. So here we have this detailed result for the anchor according to the American code. So this is an update we have received in the version 24.0. So next we have in the cut operation, the model, the extension of the member to the edge of the column. So this is the feature that the developers have brought in for using the cut operation. And then we have this template, the usage of connection library. For example, let us go to the project. In the project preferences, we have this developer mode that is already inactive. If you go to a new project, you can go with this create project. And I'm just removing the operations. We can able to use the connection library for giving our proposal over here. So we have another additional type as a connection type as parametric. This is the parametric template. So if you give an OK by choosing any of your predefined user sections, this is the user-defined parametric template that has been developed by a senior engineer, and that is being visible to all the users who are using the IDEA StatiCa in each of the company, those who procure the license. So once you click OK, you can give your recommended values and you can click OK. The operations will get reflected here. And if you want to, if the user feels to make an edit in this parameter of the template which you have chosen, you can go to the developer mode, and you can have an edit in the values over here. The column offset, the widener width can be edited. The column offset has been expressed as 0.02 mm, so it's 20 mm. The widener width, it is 200 mm. So if you, I'm just showing you an edit over here. So I'm thinking it has been changed to 300 mm now. The widener depth is 300 mm. We can maybe it's a 400 mm. Like this, the parameters being controlled with some values over here, and we can give the option of set to model. So this has been corrected. This has been edited. And the same will be observed in the design tab as well. Also, the edited model being reflected over here also in the parametric connection type. So once you used with this parametric type, you are already frequently using connection types can be saved in this parametric connection type area in the inside the connection library, and that has been controlled by some factors, and you can change it and use it as of your requirement. So this is an update that has been observed in the version 24. So next we have this sketches, yeah, reports, the sketches in the reports. The and many important task is we have to communicate our developed completed connection design model to the detailing team. So IDEA StatiCa 24.0 will give you a detailed way of we can way of communication. We can create a section over here, and in this section you can rotate this, and you can able to click the boxes, and you can increase the box size to have a clear view of the notations. So the same whatever you which is set it over here, we can observe the same in the report page. In what way you want your so for example, you can able to, this is for the column and this is for the beam. So for the beam, we can able to turn the dimension labels off if you want, and we can able to turn the member labels off. So like this customization of the sketches are available. We can turn off the valve labels also. So what you are selecting based on your selection and your edit which you are given in this area, that will be reflected in the report page, and you can able to communicate it to your detailing team. So this is the future update. And then now the software is being linked with the third party applications with the supported versions. Yeah. So we have the advanced design with the Revit software, with the SAP 2000, Stat Pro, Tekla structures. We can bring in the connection geometry from the detailing software, and we give the load here in IDEA StatiCa, and we perform the connection design in that way. Suppose if you are using the design software like StatPro, eTabs, we can bring in the connection geometry as well as the load application, load combinations also we can bring in the software, and we use the operation connecting the members from the design of the imported geometry from the design software, and then we will perform the connection design. So these are the versions that have been supported by the third-party application, which is very compatible with IDEA Statica software for performing the connection design in very small way. And then we have an update as the changing the language of the report. So in the report column, you have the option in the project item settings. You can select your preferred language of your customer, and you can produce the report in their country language. So that is an update we have in the version 24. And as we have the keyboard shortcuts, uh, as we all know, the control, yes, yeah, that has been implemented in the version 24. Save to undo, to redo, to open a project, to open a new project, and to rename any item inside the software. So next we have a detail application. As an we can go to the 3D. We can go to the detail application. We have the 3D anchoring model. Suppose if you have developed the base plate arrangement, base plate connection design in your connection module, after performing the base plate arrangement, you can bring in to the detail application for performing the rebar check over here. For example, I'm just opening a base plate model over here. You can create the project. We can once we check the load inputs and the base plate parameters, we will calculate the base plate project in the connection module first. So once the connection module it has been, we all know that concrete is calculated as a block only without any reinforcement. The anchor has been calculated according to the codal requirement. So we need to check the rebar check rebar detail for this base plate arrangement. So we can export the connection module from here to the detail beta version. So we can give a name and we can open this connection module which you have developed, and we can open in the detail application. So that is what that is an update we received in the version 24. So in the version detail application, let us see. Let me open. Let me do that activity. Yeah. So the detail application has been opened here. With the connection module is it is getting imported to the detail application for the checking of the rebar calculation from here. So here we have this base plate over here, and we have the concrete arrangement. And in the supports, we have this, yeah, the supports in all the three directions. We have the surface, the supports, the position of the supports, and we have the transfer devices. So now the if you want to change the hook type, means the anchor arrangement, You can select multi-select it, and you can select it, make it as a hook type if you want, and you can observe the load effects. The loads are automatically created over here in the detail application based on the input you have. You can, if you want, you can edit the forces from here, from the force list in all the three directions. So this is a automatically created load on top of the base plate, and then we can actually bring in the rebar assembly. So we can provide our cover over here as a 60 cover. We can give a number of layers. We can give us maybe, and the distance of the layers we can give maybe 150, and the number of layer bars in the layer, it is 2 number. If you want, you can give a 3 number also. The distance between the bars is 200. The surface code, that is, you can provide it as surface as 1. The edge, so edge is 1 actually. We can copy the same, and we can change the, we have to change to reflect the bar in the other direction. To get the bar in the other direction, we have to change the edge. Yeah, and we have to copy again the same. We have to give the number 3. We have to same copy can give us 4. So then we can go to the 1, and we can give a copy. We can change the surface as 2 here. We can copy, and we can give it as 2. So likewise, we can create a rebar arrangement from these options. So once the loads have been created and the rebar has been arranged, and we run the program, so we get the result, preliminary result, and in the check tab, we can able to observe the rebar strength of the concrete, compressive strength of the concrete. We can able to observe, and we can able to observe the compressive concrete strain. Everything will be reflected in the report, and for the anchorage, we can able to observe the bond stress for the anchor, for the anchor, and we have the force check value. Then we have the total force in the bar. We can observe the report. So in the report page, we will generate a detailed report for the reinforcement and the anchorages. So the calculation, assumption, the explanations, the detailed reinforcement strength results, the concrete principal stress, concrete principal strain, elastic strain, the compressive strength. So it's a very much useful feature. We can explore in the detailed application for the rain for rebar calculation of your base plate arrangement, base plate concrete block. Yeah. So likewise, we have 3D wall. Basically, these all comes under the in the 3D beta application. Maybe like, let me on check. If you go to the detail application, earlier it was 2D. Now in the 3D beta application, you can observe the uh, in the class as a walls, and we have the solid blocks, and we have the general beams or walls. It is an enhanced feature being updated in the version 24 to observe the rebar arrangement, observe the anchorage forces, and uh, this elaborative report can be observed from extracted from the detail application. So let us see about the wall arrangement. Yeah, you can see the same methodology. We have to observe the supports, the load cases, the group of bars, and we have the reinforcement around the openings. We can give it over here. We have to give the anchorage type, and in the check tab, after performing the analysis by clicking on the calculate button, you can able to observe the results for the strength of the concrete block, the results for the anchorage, the reinforcement, and then you have the auxiliary, the deformation shapes can be observed from here. Then we have a report for this wall arrangement. You can include the code setup. So in the report generation, you can observe the results, detailed result for this wall with the openings. So yeah, the geometry of the wall with openings O1 and O2. We have the load effects, the results, strength of the concrete, the strength of the reinforcement. With the utilization percentage, it will show. We have the summary of reactions. The basically the design has been performed based on the ultimate limit statement. The detailed result for the concrete strength, the detailed result for the reinforcement strength, pictorial representation of the stresses and strain distribution for the concrete as well as for the reinforcement can be observed over here. The anchorage result, bound stress value for the. Then we have the bill of material. Very user friendly application, the detail application. We can bring in your model from connection arrangement, concrete, wherever whatever you are doing in your concrete part within the connect as a block calculation in your connection module, that can be bring inside the detail application, and you can bring in the your reinforcement rebar in the detail application, and you can able to extract the result, your detailed result for your rebar which you are using in your concrete. So I recommend everyone to try the detail application in the trial version of the IDEA StatiCa package. So this is how these are all the major updates. Let us see some of the questions. Can we validate the results with hand calculations? Yes, available. We have the verification and validation in the support center. We can validate our results. Yeah, for any for the bolt or the for simple sample weld, Everything we have the verifications and validations in the support center of IDEA StatiCa website. Can we change the member length or it is yeah, we can change the member length from the code setup. Validating HSFG goals. Yes, we have. We will share it. Please drop your email IDs if you have. We will share the specific links for the validations to your email IDs. Validation manual available. Yes. Then we have automatic weld chooses the, it is the automatic, the grade material of the weld is being chosen by the user only. The automatic weld will propose you the size of the weld alone. Interface between StatPro and IDEA Statica possible? Yes. Okay. So now we have come to the end of the presentation. Thanks for your valuable time for the for the presentation. Thank you very much.